MCV4U1, Chapter 1, Introduction to Calculus, Session 10. In this session, we are going to work on the questions assigned in the previous session. Exercise 1.4, question number 5. Question number 5 is asking to determine limit of f of x as x approaches 4, where f of x equals 1 if x is not 4 and negative 1 when x is 4. We know as x approaches a, x is getting close to a, but x is not a. Therefore, limit of f of x as x approaches 4 is 1. This can be done by using a table of values, setting up a table of values by selecting sequences of numbers less and more than 4 and close to 4, and see the limit is 1. Question number 6. For the function f of x in the graph below, determine the following. A. Limit of f of x as x approaches negative 2 from the right side. Negative 2 from the right side. The limit of f of x is 0. Limit of f of x as x approaches negative 2 from the left side is also 0. Limit of f of x as x approaches 2 from the left side. As x approaches 2 from the left side, f of x approaches 2. And as x approaches 2 from the right side, f of x approaches negative 1. F of 2 is negative 1. Limit of f of x as x approaches 2 does not exist, since the right side and left side limit are not the same. Question 10, Part B. Limit of f of x as x approaches 2 from the left side when f of x is x2 minus 4. When x approaches 2, x2 minus 4 approaches 0. When x is around 2 from the left side or right side, x2 is around 4 and x2 minus 4 is around 0. Part D, limit of 1 over x minus 3 as x approaches 1. When x approaches 1 from right or left side, 1 over x minus 3 approaches negative 1 over 2. When x is around 1, x minus 3 is around negative 2. Part F, limit of 1 over x minus 3 as x approaches 3. If we look at the graph of 1 over x minus 3, it has a vertical asymptote at x equals 3. And the graph is the graph of the reciprocal function shifted 3 units to the right. By looking at this graph, we see as x approaches 3 from the right side, f of x approaches positive infinity. And as x approaches 3 from the left side, f of x approaches negative infinity. Therefore, limit of 1 over x minus 3 as x approaches 3 does not exist. Question number 12. Sketch the graph of any function that satisfies the given condition. F of 1 equals 1, limit of f of x as x approaches 1 from right side is 3, and limit of f of x as x approaches 1 from left side is 2. We are looking for the graph of the function that satisfies these conditions. Limit of f of x around, we are talking about the graph of the function around 1. F of 1 is 1. So we have a point, f of 1 is 1. Limit of f of x as x approaches 1 from right side is 3 and left side is 2. Right side is 3 and left side is 2. So what we need is the graph of any function so we draw two lines. There are many different graphs. This is one of them. Part B, f of 2 is 1, limit of f of x as x approaches 2 is 0. So both right and left side limit are 0, and the value of the function is 1 when x is 2. At 2 it is 1. From left or right side, both of them, it is 0. We can have any graph therefore we choose this graph. Part C, f of x is 1 if x is less than 1, and limit of f of x is 2 when x approaches 1 from the right side. Less than 1 is a horizontal line, y equals 1. Y equals 1. It's a horizontal line. And more than 1, we don't know the function. The only thing we know is limit of f of x is 2. The limit is 2. We choose this graph for the function. Last question. F of 3 is 0 and limit of f of x as x approaches 3 from the right side is also 0. F of 3 is 0. Limit of f of x as x approaches 3 from the right side is also 0. We choose this line, and we don't have any information from this function, so this is the simplest graph that we can have for part D. Thanks for watching.